So today we are looking at a really pivotal moment in the history of science.
Yeah.
We've got a whole stack of historical records here, diagrams, letters,
Yeah.
all pointing to the year 1668.
It's such a key date. It really marks a massive shift in, well, in how we see the universe. We're diving into the invention of the reflecting telescope.
And our mission here is to understand how Isaac Newton took this crisis in optics, where telescopes were literally hitting a physical wall and just flipped the physics on its head.
Right. He took a device that was trending toward the size of a building and shrank it down to something that could fit on your desk.
And in doing that, he basically changed astronomy forever.
He really did. From a hobby for the rich to a serious, accessible science.
Okay, so let's set the stage. What was this technical problem? I mean, the sources we have paint a pretty bleak picture of 17th century astronomy.
It was bleak. You had these brilliant minds, Galileo, Kepler, but their tools were holding them back. They were using refracting telescopes.
So tubes with glass lenses?
Exactly. And they were all running into this one big problem, chromatic aberration.
A rainbow effect.
That's it. It's a fundamental issue with the medium. A glass lens, it doesn't just bend light, it acts like a little prism. It splits white light into all its colors.
So the blue light bends a bit more than the red light, and they never come to the same sharp focus.
Right. So instead of seeing a crisp planet, you see this blurry blob with this sort of psychedelic halo around it, totally useless for precision.
And the workaround they came up with was
Yeah.
just wild.
Oh, it was incredibly impractical. Astronomers figured out that if you made the focal length absurdly long, the color separation was less noticeable, and that led to the age of so-called aerial telescopes.
I was looking at the diagrams for these. They seemed impossible to use. We're talking about Huygens designing these tubeless telescopes that were, 50 meters long?
50 meters. Yeah, just try to picture that. You've got a lens on top of a giant pole and an eyepiece held by someone on the ground, and you're trying to align them while the planet is moving.
It's a nightmare. Unstable, expensive.
Barely usable. And that's the context where Newton comes in. He looks at this whole engineering mess and has this incredible insight.
That they're solving the wrong problem.
Exactly. The issue isn't the quality of the glass, it's the refraction itself. It's the fact that light is passing through something.
His aha moment was that reflection is different.
A mirror bounces all the colors, all the wavelengths back at the exact same angle. No prism effect, no rainbows.
But it wasn't as simple as just swapping a lens for a mirror.
Right.
The tech to make a good mirror for a telescope,
Yeah.
it didn't exist.
He had to invent it. He couldn't use normal silvered glass that would create ghost images, so he cast his own mirror out of something called speculum metal.
A mix of copper and tin.
And, this is a great detail, he used arsenic in the polishing process to get that perfect reflective surface.
Which is incredibly dangerous.
Yeah.
But it worked.
It did. He made this concave mirror to gather the light, but then you have a geometry problem. If the mirror is at the bottom of a tube, how do you look at the image without your head getting in the way?
And that's the classic Newtonian design. He puts a tiny flat secondary mirror near the top, angled at 45 degrees.
To just kick the image out the side of the tube to an eyepiece. Simple, but utterly brilliant.
And the result was staggering.
Completely. These aerial telescopes were giants. Newton's first reflector was just 6 inches long.
6 inches versus 50 meters. That's an unbelievable evolution in the technology.
And that tiny 6-inch tube had 40 times magnification and gave a clearer image than refracting telescopes that were 12 times its size.
So he points this little prototype at Jupiter and sees the cloud bands. No halo. Crystal clear.
But the real impact goes way beyond just clearer pictures, doesn't it? It changes our whole relationship with the cosmos.
It broke the solar system wide open.
It did. You fast forward about a century to 1781, William Herschel builds a bigger Newtonian reflector, points it at the sky, and discovers Uranus.
The first new planet found since antiquity. Before that, the universe ended at Saturn. That was
Right.
the known boundary.
Herschel shattered it. And that gets to the societal shift. Mirrors are cheaper to make and easier to support than huge, heavy glass lenses. It democratized the whole field.
So you didn't need a king's budget to build a powerful telescope anymore.
Right. More people could get involved. They could start cataloging nebulae, discovering new things, realizing the universe was this vast, explorable place.
It's really the direct ancestor of the huge observatories we have today, isn't it? Keck, the VLT.
They're all reflectors. They're just gigantic, incredibly high-tech versions of that little 6-inch tube Newton built.
It is incredible. The idea that to see further, we had to stop looking through things and start looking at the reflection.
And it makes you wonder, doesn't it? What other huge unsolvable problems are we stuck on right now just because we're trying to perfect an old method instead of flipping the physics entirely?